So we just coded our first logistic regression model, taking full advantage of the PyTorch API. So when we did that, we normalized the input features. And in this video, I want to briefly explain why we actually did that. So suppose we have a real-world dataset like this wine dataset, where the goal is to predict the wine quality from these different input features. And you can see certain feature columns have values that are much larger than other feature columns. And the fact that these features are on various different scales can actually be a problem for the learning algorithm. To understand why features on different scales are a problem for the gradient descent algorithm, let's take a look at the weight update again. So for the weight update, we first compute the gradient of the loss and then we multiply it by a learning rate. And the product of that is then added to the weight vector. So if we look at the gradient more closely, it consists of these individual partial derivative terms. And if you recall the chain rule, each of these partial derivatives depends on the feature inputs. So if the features are on different scales, all these partial derivatives will be on different scales. And if these partial derivatives are all on very different scales, it will be very hard to find a good learning rate that works well for all these different terms. So in essence, the main advantages of normalizing features is that it is easier to find a good learning rate that works for all these partial derivatives. And as a result, we will get numerically more stable gradients and the training will be faster due to faster convergence, which essentially means that we need fewer training epochs. So this was in a nutshell why we care about normalization. And in the next video, let's take a look at how we do normalization.